And again, you have to be looking at the denominator after your wholes are canceled, right? If anything went away, don't be setting that equal to 0. You're going to screw yourself up, all right? Does this all seem to make sense? Like from the picture and what we've, like the connection, everyone see, like why we're doing this? All right, the fifth step's the most confusing. The fifth step says we're going to find the horizontal asymptote. And to do this, we are going to first compare the degree of the numerator and denominator, right? Compare the degree of, I'm going to put n and d. Is that all right if I say n and d for the numerator and denominator? You're going to compare those degrees, all right? Now, there are 3 possible outcomes at this point. The first outcome is this. If the degrees are the same, okay? If the degree of the numerator and the degree of the denominator are equal, that's what we've just looked at, right? If that happens, then y equals, what was it? Like on that one, it was x squared minus 4x minus 5 over x squared minus 25. The degrees were equal, right? So if the degrees were the same, then what was it? It was y equals what? This divided by that? 1 over 1. How do I say this divided by that? Well, this is the what of this? This is the what? Leading coefficient of the numerator, right? And this is the leading coefficient of the denominator. So y will be equal to the leading coefficient of the numerator divided by the leading coefficient of the denominator. That's what it will be if the degrees are the same. Okay? If they're the same, that's what's going to happen. Questions? I don't understand what I mean by this. Leading coefficient of numerator divided by leading coefficient of denominator. Okay, now the other case, if the degree of the numerator is smaller than the denominator. Now, I did show you one of these cases. It was the very first example I did. That one right there. What's the degree of the numerator here? This is a tricky problem. What's the degree of the numerator? What's the power on x? No, that's the denominator. That's 1. It's really an x to the 0. So what's the degree of the numerator? 0. What's the degree of the denominator? 1. 0 is smaller than 1, isn't it? Do you remember what the horizontal asymptote was here? It was the x-axis. It was the x-axis. Then y equals 0, or if you like, that means the x-axis, right, is your horizontal asymptote. Last case would be what? If the degree of the numerator is bigger than the denominator. I have not shown you one of these, okay? That I have not shown you. But if this happens, here's what you get. You have no horizontal asymptote then. You won't have any. Because the way you can think about it is that, okay, so here's the best way I can think about it. I can help you think about it. If I've got this, right? Look at this here. This is the highest power of x, right? So as x gets big, that means as I go out to the right, as x gets big, these two things don't really matter because they have lower powers on x. So these are really insignificant. And so we're really looking at this, right? And then the same thing on the bottom. This is the highest power, so I really can ignore that. And if I take x squared and divide it by x squared, or 1x squared divided by 1x squared, I just get 1, right? But imagine that this was no longer here, right? Like this. No, sorry, I want the other way around. Let's imagine that this was linear instead, right? Then this top is really like x squared, and the bottom is really like what? But this minus 25 doesn't matter because this has a higher power than this. So it's really like an x. And That's x squared over x is x, right? And what does x do? What does that function do as you go to the right? It increases, right? But it doesn't flatten out. That's what's happening. So we have no horizontal asymptotes, and I'm going to add one more thing here. No horizontal asymptotes, so it acts like a polynomial. And I'll explain that more when we get to an example. So in the case that the degree of the numerator is bigger than the denominator, the end behavior is going to be like a polynomial behaves. Okay. That's the steps. I'm going to put one more thing here. Remember the verticals right here, right? The verticals. These are barriers, right? Those are barriers. You can't cross those. Horizontal asymptotes are the end behavior. End behavior, they're like magnets, right? That pull your graph at the edges only, right? At the edges. And of course, x-intercepts are just x-intercepts. All right, that's it. Got it?
Yep.
Okay, I'm going to erase it. And we're going to do an example. And we're going to go right to the homework. And let's do number 8 to start. How are we doing on time here? Okay. Yeah. All right, sketch this. F of x, we're going to do number 8 to start. I'm going to use f of x instead of r of x. F of x equals, we've got x over x minus 1 times x plus 2. All right, is that a rational function? Yes, it is a polynomial over a polynomial. But they've already factored it for us. Isn't that nice? So let's do step 1. Step 1, we factor, right? Done. Step 2, are there any holes? No. Done, right? A hole would be a common factor we can cancel, right? Nothing to cancel. All right, step 3. Does anyone have a question? You all right?
So x-intercept is 0.
X-intercepts would be this. X-intercepts. So what do we do to find the x-intercepts? Set what equal to 0? Numerator only. So I set the top equal to 0. And hey, guess what? That's it. X is 0. All right, now we want to find the vertical asymptotes, right? Vertical asymptotes. To do that, we set the denominator equal to 0, right? And it's already factored. Isn't that nice? 1 end, negative 2. What if you set both the top and bottom? I'm not sure I understand.
If you make x 0 for the top, would x for the bottom be 0 as well? If they were both equal to 0, what would happen?
Then you would have had a hole.
Okay.
So when we would have canceled that. Does that make sense? Like if there's something that makes the top and bottom 0 at the same time, that would have been a hole.
So,
Are you saying that these could somehow become 0 together?
So finding the x-intercept, you make the x on top 0.
Yes.
But that's 0 divided by what's on the bottom. And if the x is 0, the other x's are 0. If somehow the bottom with the zeros ended up becoming 0 as well.
Good thought, but that wouldn't be possible because then you would have common factor. Like there's no way to, think about it. The only way to make this 0 is what? 1? The only way to make that 0 is negative 2. And the only way to make the 2 together 0, because there's multiplication, is if one of them is 0, right? You can't do, this can't be a number and this be some other number and they somehow multiply to be 0 unless one of them has to be 0, right? So if 0 makes the top 0, then it's impossible to make the bottom 0 as well unless there was an x out here. All right, good? Questions at all? All right, fifth step. Oh, wait, hold on. I've left something completely out of my steps. It's okay. We'll get to it. We'll get to it. You're going to have to go back and add something to the steps. I apologize. Horizontal. All right, step 5, horizontal. Okay, what is the degree of the numerator? What's the degree of the denominator? So this actually, because it's factored, we have to think this through a little bit. Degree of numerator is what? 1. Okay, I hope that's obvious, right? That's 1. However, the denominator, because it's factored, when we're looking at its degree, we would have to multiply it back together. Can you all tell just by looking what the degree of the denominator would be? X squared, right? So it'd be 2. All right, what's the relationship between these? The numerator is less than the denominator. And wasn't that in our notes case 2? And what does case 2 tell us? Y equals 0. Is that a question? No, okay. Y equals 0, or the x-axis, however you want to look at it. Okay? All right, I think I only gave you 5 steps, right? Yes? 6? It was just these 5, right? No? 5 or not? 5? Okay. All right, there's more. We have to sketch the thing, right? We have to sketch it, right? So there's going to be a step 6, but I don't want to write down step 6 yet. I want you to see why we need step 6. Right now, what I'm going to do is I'm going to try and graph it. And you'll see when I try and graph it, I don't have enough information yet. I don't know enough to graph this. You ready for the graph? Yep? Okay, good. Here we go. I'm just going to draw XY axes. And let's start off. The graph, the actual graph, the final picture is going to be in blue, all right? So the x-intercept here is 0. That is a point on my graph, right? Okay, I can put that on here. X-intercept 0. There it is. Bam. Got it. That's part of my graph for sure. All right. Then I have what? Vertical asymptotes, right? 2 of them. At where? 1 and -2. Now, what are vertical asymptotes? They're vertical barriers, right? They're not really part of my function, but they help me draw my function, don't they? So at -2, I'm going to come to the left 2. At -2, there's -1. Here's -2. What I'm going to do here is I'm going to draw a vertical dotted barrier that goes up and down through my graph like that. And then I need another one at 1, don't I? Another vertical barrier like this. Right. Now, I had a horizontal asymptote of y equals 0, which was the x-axis, right? What does the horizontal asymptote tell us? It's the magnet, yes, but it only tells you about the end behavior, right? The end behavior only. So watch the way I draw my horizontal. Don't want to do it in blue, I'll do it in green. At the left edge of my graph, I'm going to draw a dotted line continuing my x-axis this way. And then on this edge, I'm going to draw it like this. What I am not going to do, and what a tutor will probably do and confuse you, is they're going to draw a dotted line all the way through. Do not do that, okay? The horizontal asymptote only tells you about end behavior, so only draw your dotted line at the edges. If you draw it in the middle, it's going to screw you up. It's going to confuse you. You're going to think it's a barrier. You're going to think you can't cross it. No, the horizontal asymptote only tells you what happens at the left edge and the right edge of the function, okay? All right, there's everything. Here, I'll color code this. This right here was y equals 0. That's on the graph, only at the edges. Here's my 2 verticals, my dotted barriers. And then the blue part here was my x-intercept. Right? So I have put all the information on the graph. Yeah? That's not enough. That's not enough information. Do you all agree? I don't know what happens here. What I do know is that when I finish drawing this, this better be a function. So it better pass the vertical line test, right? The good old-fashioned vertical line test. But there's so many different ways I could draw this. So many different ways, right? So why don't we cheat a little bit all right? And let's look at what it looks like from the computer. Let's type this in. X over x minus 1, x plus 2. Whoa. Okay. Shit, how are we going to get that, right? How are we going to get that picture?
Plug numbers.
Exactly. So hold on. Let me put my vertical barriers. My vertical barriers were at x equals -1. No, -2. And the other one was at x equals 1. And those were my dotted, what are they, red over here? I'll make them red there. I'll make that blue. Look, this is going to match exactly what I have. Okay, that's what we have so far, right? I didn't draw my horizontal, but that's what we have. That's what we have so far, right? How are we going to get? How do we know that this does this, right? How do we not know it doesn't, do this? Or what tells us it doesn't come down and maybe bounce off and go back up, right? There's a lot of things that could have happened here. It could have come this way and bounced off and come this way, right? Over here, what's happening? It looks like it's like this, right? Like this. Why isn't it like this? Over here, same thing. Why is it up here and not down here? So I've got to figure that out, right? You have to figure that out. So here's the standard approach. The standard approach is that we are going to look at these two pieces of information. So this is step 6, all right? This is step 6. We call this the test point step. Test points. Test point, test points. What we unfortunately have to do is we have to pick some points to help us graph, all right? We need just a few more points. If we knew where those points were, then we could draw the rest of the graph. The question is, how many test points do you need, right? So here's the way you determine how many you need. How many x-intercepts do I have? 1. How many verticals do I have? 2. We don't worry about these. For test points, we don't worry about horizontals. We only look at x-intercepts and verticals. I have 1 and 2, so that's 3 total, right? 3 total. You will always have one more test point than the total number of x-intercepts and verticals together. So if I have 3, right, 1, 2, 3, if I have 3, I'm going to need 4 test points for this to work, all right? So I'm just going to put under here, I have 1 x-intercept, I have 2 vertical asymptotes, right? Which means I'm going to need 4 test points. 1 and 2, that's 3, one more than that. Now, the question is, where do you choose them? You can't just pick them wherever. You have to pick them carefully. So the first test point, what I do is I come to the left of my graph, and I see the first thing I have, the first vertical I have is here. I must pick a test point over here. I'm going to put an X through there. Don't put a dot. Why not a dot? Because you might think it's an x-intercept, right? I'm just telling you, I'm going to pick a point over here. I'm going to test that point out. Can someone give me a point over there? -3. Could I have used -4? Yes. -5? Yes. Anything you want. It just has to be over there. So -3 seems right. I'm going to take it. I'm going to circle it. That's the way I like to do my test points. An X with a circle around the number. Okay. So that's to the left of this vertical. Now, y'all see this vertical, and the next piece of information I had was this x-intercept right there. I need something in between those. What's that number? -1, right? -1's a good test point? No, 0 is here. You can't use the x-intercept as a test point, because you already know what happens at 0, right? At 0, you're right there. You need to know what's happening over here. Good? Now I need another test point between here and here. Unfortunately, it's going to have to be a decimal or a fraction, right? I'm going to put a half here. How many do I have? 1, 2, 3? One more. One more test point. Over here, something, anything. 2? Okay, 2. All right, those are my test points. So my test points are -3, -1, 1/2, and 2. We're almost done, okay? And what do I do with those test points? I want to know where they are on the graph, right? I want to know what happens when I plug those values into the function. Whether or not, when I plug in -3, I want to know whether or not I'm up here or down here. When I plug in -1, I want to know if I'm up here or down here. When I plug in 1/2, I want to know if I'm up here or down here. And at 2, I want to know if I'm up here or down here. Make sense? Yeah? So we got to evaluate the function now. I'm going to do that right here. Still in step 6. So now I need to know what f of -3 is. I need to know what f of -1 is. I need to know what f of 1/2 is. And I want to know what f of 2 is. All we care about is whether or not I'm above or below the x-axis. If there's a point up here or down here, we don't care how high it is or how low it is. Just, is it up here or down here? So when I do that, when I plug in -3 in here, watch what happens. Watch what happens. If I plug -3 into this, don't worry about the numbers, okay? Just tell me about the signs. -3 right there gives me a negative number, right? -3. So my top is negative. I'm dividing that by, what's -3 take away 1? -4, that's a negative number. What's -3 plus 2? Negative as well, right? Okay. So I have a negative on top. What's the bottom really turn out to be? Negative times negative? Positive. So I have a negative over a positive. What's a negative divided by a positive? Negative. You understand what I'm doing there? Instead of like figuring out exactly what the numbers are, I'm just looking at what the signs turn out to be. I have a negative number on top when I plug in -3. -3 take away 1 is -4. -3 plus 2 is -1. Two negatives become positive. Negative up top, negative over positive is negative. Now, I'm going to get my blue marker out. I'm ready to put a point on the graph now. At -3, I know that my point comes out to be what? Negative, right? I don't care where. I'm just going to go down. I'm going to draw a dot. I don't care about where, okay? It's just that it's down. Got it?
We're only really worrying about the signs.
That's right. Let's try -1. If I plug -1 into the top, what do I get? Negative number over, okay. What's -1 take away 1? -2. What's -1 plus 2? Positive, right? Okay, on the bottom, what's a negative times a positive? Negative. So you have negative on top, you have negative on bottom. What's a negative divided by a negative? Positive. So that means when I'm at 1 over here, -1, sorry. When I'm at -1, what happens? Positive answer? Anywhere I want, right? Anywhere. I don't care. Doesn't matter. I'm just going to put it there. Okay? Two more, and then we're ready to draw it. Okay, let's try a half. If I plug 1/2 in here, what's 1/2? It's positive, right? Over. Okay, be careful here. What's 1/2 take away 1? Negative, right? Negative a half. What's 1/2 plus 2? Still positive, right? Still positive. Okay, negative times positive is negative. So we have positive over a negative, which is negative. Do you notice that they're switching? Yes? That doesn't always happen. You have to check, all right? So at a half, I am negative down here. And then finally, we plug in 2. If we plug in 2, I think they're all positive, right? Positive, positive, positive. And so my answer is positive. And so over here at 2, we have a positive number right there. Okay. Isn't this fun? Rational functions, pain in the butt. All right, time to put it all together. And this is where you have to be thinking about what all these dotted lines, magnets, barriers, what they all mean. I need to draw a function, right? I need to draw a function that passes the vertical line test, right? That gets magnetically pulled towards this. When it reaches this barrier, it like freaks out, right? and can't cross that barrier. And I've got to have that x-intercept, right? I've got to put this all together. So this is the way I like to do it. I like to start with the leftmost point that I know exists on my graph, which is that one right there. Okay? I'm going to start right here. And what I'm going to do is first look this direction. What has to happen when I draw this way? Well, I see a magnet, don't I? I need to go towards the magnet. Come to the magnet. There. It's there. Right? That's what happens over there. Then I turn, I look this way, and I say, okay, what happens here? Well, I have a barrier, right? Barriers say you can't cross them. So that means I either have to turn up or I have to turn down. Which one is it? Down. Why down? Because it looks like down? There's a reason it has to go down. No, because the horizontal's only out here. You ignore that. What would happen if you turned up? What would happen right there? You would cross the x-axis, and where's the only place you're allowed to cross the x-axis? Right there. So by turning up, you're creating an x-intercept that doesn't exist, which means it has to go the other way. So that means I'm just going to draw it like this and drop down like that. Kind of looks like that, right?
Do you put the actual number in? If you actually solved it, got the point, you actually know like where the point's at?
You would know, yes, but you'd only know one point, right? Like you would just know one of those points, right?
Like on the test, we just do like that.
Just like this, yes. This is like the same with polynomials. When we were doing polynomials and we like bounce, cross, we didn't care how high up or down. Same sort of thing. We don't really care what's happening in here. What we care about is that it flattens out here, it dives down there, and over here, it's below the x-axis. That's all we care about.
Ballpark.
Ballpark, yep. Cal 1, then you get into the details. All right, so I'm finished with this point, right? I went to the left, went to the right. Now, jump over my vertical, come here, here's my next point. Let's go this way. So if I draw this point this way, what happens? Barrier, right? Barrier is going to force me to either go up or down. Which way? Up. Why? Because it looks like it? No, because if I turn down, what happens somewhere here? X-intercept. I can't create an x-intercept that doesn't exist. So that means this has to go up, right? So from here, it's going to turn up. Let me try and do all this at one time. I know this is going to go up. And then from here to here, I'm back in kindergarten. I'm connecting dots, right? Connect dot, connect dot. And then as you draw to the right, barrier forces me either to go up or down. Can't go up because I'll create an x-intercept, so I must go down. So all of that together looks like this. Which is what that looks like. And then final point, we jump over here, we get this point this way, barrier, right, can't come down, have to go up. And then to the right, what happens? Magnet pulls me down. Put those two pieces of information together, you've got this and that. There it is. What do you think? A lot of work? A couple of places you can go wrong, huh? So here's what I'd like for you to do for homework. Let's do I'll tell you where this is from in a second. Let's do numbers 7 through 30. No, I'm kidding, not that many. Let's, just for the sake of starting out, let's do, I'll highlight what I want you to do here. Let's do number 7. I'll give you an opportunity to take a picture of this if you don't want to have to go look it up on the ebook. Let's do number 7. Let's try number 9. Let's try number 18. See how that goes. Maybe one more just to see how it goes. One more. I want to make sure it factors. Yeah. Well, we haven't done one like that, so I don't want to give you something we haven't done. Yeah, let's just do. Yeah, let's just do those 3. I think that's, at least because I've only given you one example of this. See how it goes. Can everyone see those all right? Take a picture if you need to. I'm not going to collect this for a grade, but please try these before we come back because I'm going to get right into some more. Look, eventually, what your problem is going to look like is going to be like this. Remember those homework problems remember that? Ultimately, what I'd like to be able to do is give you something like this, on top of this. And then you know how to factor it, right? You have to use your synthetic division and all that. And then you have a bunch of x-intercepts. You have a bunch of verticals, right? So it's going to be tedious, but I'd like for you to be able to handle that at some point. All right, that's your homework for the day. I'll see you on Thursday. I'll try and get a review out. Thank you. Oh yeah, I'll tell you what section I'm in, just so y'all know. If you're keeping track here, I am looking at page 376. Page 376. So I'm looking at 5.4 and 5.5. 5.4 and 5.5. So we skipped 3.7, or 5.7, sorry.
I have a question.
Yes.
I was talking to my advisor and he was
Can I turn my
Yeah.
thing off? Okay. Come on up.
Remember those problems you told me to do?
Oh, you have those? Okay.